A pair of sine curves are given. y1 equal 10 sine of 3t minus pi over 2, y2 equal 10 sine of 3t minus 5 pi over 2. Find the phase of each curve. Find the phase difference between the curves. Determine whether the curves are in phase or out of phase, and sketch both curves on the same graph. The phase of each curve is the term after the minus sign inside the function. And we won't need to factor out the 3. The phase is not the horizontal shift. To find the horizontal shift, we would need to factor out 3 in this case, but the phase shift is whatever it is after the minus sign in the unfactored form. So if it is in the factor form, we have to distribute the constant multiple in front of t. And so in this case, for the first curve, the phase is pi over 2, and for the second curve, the phase is 5 pi over 2. Again, it is not in the factor form. B, find the phase difference. We just simply take the phase from the second equation in the order it was given. And so y sub 1 and y sub 2, it matters which one is given to us first. We take the phase from the second curve and subtract the phase from the first curve. This is 4 pi over 2 or 2 pi. If the difference is exactly 2 pi, then we would say that these are in phase. And if they are in phase, then the curves are identical. And so we only need to grab one curve, because if the two curves are in phase, then their graph coincides. To graph the two curves, which is only one curve here, we would factor out the 3 so that we know what the horizontal shift is. Y equals 10 sine of 3, and then factor out 3, we get t minus. If we have pi over 2 and we factor out 3, we get pi over 6. And so even though the phase shift is pi over 2, the horizontal shift is pi over 6. Pi over 6 is the start of one cycle. The period is always 2 pi over omega, and so the period is 2 pi over 3. Starting with pi over 6, we would need to add 2 pi over 3 to get the end of the cycle. Multiply 2 top and bottom, we get 5 pi over 6. And so if we start the graph at pi over 6, we would end with 5 pi over 6, and in the interval pi over 6 to 5 pi over 6, we will get one complete cycle of sine. To do this, we will take the period, which is 2 pi over 3, and we divide it by 4 to get 2 pi over 12, or simply pi over 6. And so we start with pi over 6. The increment is another pi over 6, so it is 2 pi over 6, and then 3 pi over 6, and then 4 pi over 6, and then 5 pi over 6. From pi over 6 to 5 pi over 6, which is a distance of only 2 pi over 3, we have 1, 2, 3, 4 quarters. The graph of sine starts in the middle, starting at pi over 6, and then high, and then back to the middle, and then low, and then back to the middle. The highest point is 10, because the amplitude is 10, and the lowest point is negative 10. Armed with these 5 points, we can connect them to form the sine curve. This is the graph of both curves actually, because they are in phase. And so if we were to graph tan sine of 3t minus 5 pi over 2, we will end up with exact same graph. Usually, we would graph the cycle starting at the horizontal shift, but remember that the graph of sine oscillate forever back and forth. The domain is a set of all real numbers, meaning for another period of 2 pi over 3, we would get an identical cycle. Even though we start with the horizontal shift, we want the complete graph maybe starting at t equals 0. Using symmetry, if this is middle, high, and then middle, low, and then middle, going back, again, if it is middle, high, going forward, then it should be middle, low. To fill in the graph for the interval 0 to pi over 6, we would simply connect the curve.